Section 4. You will hear part of a university seminar given by a student. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good afternoon, everyone. In today's seminar, we're going to continue listening to different students giving us a presentation on the subject of their term paper. Now, today is Hillary's turn. So, what are you going to talk about today, Hillary?
Well, some of you will know that I was brought up when I was young in Japan, and I'm going to do my term paper on Japan's bullet trains, which have revolutionized their rail industry. Japan's main island, Honshu, is covered by a network of high-speed train lines that connect Tokyo with most of the island's major cities and Fukuoka on the island of Kyushu. Japan's high-speed trains are called Shinkansen, but are known to us as bullet trains. The Japanese bullet train system is credited with being the world's first purpose-built high-speed railway, and the model and inspiration for all other similar type systems running today, such as the French TGV. The reputation it has earned for safety, speed, and punctuality is unsurpassed. I'd like to give you some figures about that. As regards safety, there has never been a death on the bullet train system since its inception in 1964, other than that caused by deliberate passenger misadventure. As far as speed is concerned, the bullet train holds the current world record for the fastest average speed between two station stops, which was 261.8 kph between Hiroshima and Kokura. The train travelled 192 kilometres in 44 minutes. This record is from the 500 series Nozomi trains, running at a maximum speed of 300 kilometres an hour between Shin Osaka and Hakata. I'll talk more about them later. The punctuality puts European train services to shame. Most trains arrive at their destination after several hours to within the second. In 1 year, the total time that all bullet trains were late by was 12 seconds. This statistic is hard to believe, but it would be difficult to prove otherwise, and that's what the rail authorities in Japan have told us. Now I'd like to tell you a bit about their history. The first bullet train was introduced in 1964 by Central and West Japan Railways for the Tokyo to Osaka route. Most of these old trains have now been discontinued. There have been several bullet train models since then. The most recent ones have been the 300, 500 and 700 series, and it's the 500 series one that can travel at 300 kph. The bullet trains operating in Japan today are of the three following categories: Nozomi, Hikari and Kodama. The Nozomi trains stop only at the most important stations and reach Osaka from Tokyo in only about 2.5 hours, and it's the most modern of bullet trains that serve as Nozomi. Hikari trains stop a little bit more frequently than Nozomi trains and need roughly 3 hours to reach Osaka from Tokyo. Kodama trains stop at all stations, and they are the local trains among bullet trains. Older models of bullet trains serve as Kodama. I'd like now to talk a little bit about the technology involved in bullet trains. The Shinkansen bullet trains consist of electrically powered cars. That means basically all individual cars are equipped with electric motor driving systems. This is in contrast to locomotive trains, in which the locomotive pulls the passenger coaches. The realization of the high-speed Shinkansen with the electric train system had a great significance. The French train à grande vitesse, or TGV, runs on a centralized power system, in which the heavyweight, high-output locomotives at both ends pull the passenger coaches. It's a system suitable to European railways, which run basically on straight tracks in wide plains with solid foundations. However, it is unsuitable in Japan, where the ground is flimsy and the tracks full of curves and undulations, and intercity distances are short, making it necessary for the trains to accelerate and decelerate frequently. One of the advantages of the electric car system is that the motor functions as a brake to reduce the speed of the train. When the power feed to the electric car motors is stopped, the wheels continue revolving, keeping the motors rotating, resulting in electricity generation by magnetic induction. As the force acts in the direction opposite to the axle's motion, it functions as a brake to the train. All the motors equipped on each coach can be utilised effectively to reduce the speed, making the electric train system advantageous on Japanese railways, which involve frequent deceleration and acceleration. In addition, by virtue of the remarkable progress achieved recently in semiconductor technologies, the electric train system has undergone tremendous improvements in power, operability and safety administration, so the system is becoming increasingly advantageous.
That is the end of section 4. You'll now have half a minute to check your answers.